All right, let's talk about Chapter 4, vocabulary. There are some things that are key differences here, key ideas that will show up throughout the course. And the two big ones on the board right now are population versus sample and bias versus variability. Let me first of all describe the example we're going to deal with. The example is where I have decided I want to try to figure out what the average August electric bill is for families in Swansea. There is the idea that I can go out there and ask every single family in Swansea what their electric bill is for August. And if I manage to get all of those bills, then I would have a look at the entire population. Population doesn't always mean people. In this case, it means bills, all electric bills of families. I'm not surveying the families, I'm surveying the electric bills. If I manage to get all the electric bills in Swansea for August, that's the whole population I want to know about. But generally, we don't bother getting the entire population in one place so that we can survey them. Usually what we do is we take a sample, a small group of items from the population. If it's in people, we can call them individuals, but sample just means a group from the population. And we measure those, like if I asked my students to bring theirs in, those bills that I see would be the sample. And pretty much always we're going to take a sample because getting the entire population is usually very difficult. At least in cases that we're going to see in this class. Otherwise, there's no point to much of this course. If you can get the entire population in one place and sample all of it, make the entire population be the sample, then you really don't need this course. This course is all about what to do when you don't really have access to the entire population, and we usually don't. And that's what makes this course worthwhile. So how do you gather a sample? Well, there are three ways you can do it. One is you can take a census. That is when you survey the entire population. Usually that's hard to do. The government runs a census of US households every 10 years where they try to get absolutely everybody surveyed. And your parents will probably fill in the next one, and so will you, in 2020. And the last time was 2010. It's part of the Constitution, actually, that you're supposed to do a census every 10 years to figure out who lives where. But usually that's too hard. Usually that's too expensive. Usually it's not worth our time. And so one of two other things are done. Either a convenience sample is gathered or a random sample is gathered. A convenience sample is when you grab a sample that is convenient to reach. For example, if I grab my classroom and I tell them to all, bring in your electric bills from August, that's much more convenient than doing what you should do, which is a random sample. See, I just grabbed the most convenient examples. It's hard for me to go, driving all over the place, all over Swansea, to get like a little from every neighborhood. So I'll just grab the 10 students. It's hard for me to find people who only work third shift, people who only work second shift, to get like a proper mix of everything. So a convenience sample, well, it's convenient, so I gathered numbers, but I might have missed something important, and we'll talk about that in a little while. A random sample is when you find out what the entire population consists of, and then give everybody an equal chance to be chosen. Let me read you the textbook definition briefly. Convenience sample, choosing individuals from the population who are easy to reach, results in a convenience sample. And then you have, as opposed to that, a random sample. Random sampling involves using a chance process to determine which members of a population are included in the sample. I'm going to go farther. For the purposes of this course, random sampling means everybody gets an equal chance of being part of the sample. It's as if I look through the phone book, or actually a list of all addresses rather than people, and numbered them 1 through like 15,000 or however many households there are here in Swansea. And then I, basically flipped a coin first half or second half. Flipped a coin, well, that's a long way of doing it. Got a random number generator, like some dice, to pick me a random person from this whole set of all people in Swansea. And then it did it again until I got like 20 people. Or if I chose I named all the blocks, numbered them 1 through whatever, and then surveyed 7 of those blocks chosen also randomly, using dice or whatever. So there's a lot of different ways to do random sampling, and there's several ways to get convenience samples, one of which I will highlight for you guys. But those are 3 different ways to get a sample. And usually the last 2 are used because the first one is incredibly difficult. Let's imagine a situation where we're trying to figure out if the chocolates created by a factory are of high quality. So do I go to the nearest conveyor belt and grab the first 10 I see and eat them? Well, that would be a convenience sample. Yes, I'll know if this batch is good, but what if there was a different batch that comes out a little later that's no good? Since I surveyed them all from the same place, I might have a wrong impression of how these, chocolates are coming out. Maybe just as I reached to, grab 10 from the conveyor belt, that's when there was malfunction, a little something oozed in, I don't know. And so I end up with 10 chocolates that are all gross, and I think that, I have to shut down the whole factory and rethink everything. Convenience samples can have issues, so we want just a random sample whenever possible. A census would be ridiculous. There's no way I'm going to eat all the chocolates in the factory to figure out if I am creating high quality chocolate. So now let's take a look at some of the things that can go wrong. And there's really 2 categories for how things can go wrong. Bias and variability are very different. People always use the word bias when they mean variability. Be careful of that. Variability is when you're off from the truth due to pure random chance. So let's say I'm doing my survey of which houses, of electric bills in Swansea, and I get an average of $75. But it just so happens that because I did a random sample, I just so happened to end up with 10 people with very large houses and very large electric bills. Bad luck. That's a situation of variability here. The true average may be $75, while my average that I get, due to random bad luck or chance, was actually $120. Or I so happen to survey 3 people who don't use cooling at all because they moved here from tropical countries and AC is for wimps. So their August electric bills are very small. All of those things, anything where I might miss the truth due to pure chance of who I happen to survey, that is variability. Any situation, if the average is 75, that doesn't mean that every single one of my electric bills that I survey is going to be 75. The fact that some may have higher and some may have lower electric bills, that's also a situation of variability. Bias, on the other hand, is really bad. We try to avoid that. That is when we are off because of the way we did things. Let me read you the textbook definition. This is page 212. Bias. The design of a statistical study shows bias if it would consistently underestimate or consistently overestimate the value you want to know. Let me give you an example. Let's take the example where I grab 10 of my students and tell them to go home and grab their electric bills for August. They come in and they bring me their electric bills, and their electric bills are somehow all between $75 to $130. Now, does that make me suspect that the average electric bill in Swansea is between $75 and $130? Yes, it does. But every person who I surveyed lives in a household with at least 2 people, themselves and their parents. Well, their parent. Possibly 3 people if they have 2 parents at home. Possibly 4 people if they have, a sibling or more. That nobody there is living on their own. So what I end up with is a whole bunch of people who all live in multi-person households, and that's going to set things off. Because there's no way I'm going to end up with anybody who lives on their own. I'm going to suffer from systematic error because of how I created my survey. And that's what bias is. Because I gathered my data in a way that meant that I couldn't end up with any people with only one person living there, my method has error built into it, and that error is called bias. Now, let's say that due to some miracle of chance, I end up still ending up with 75 as the average. Maybe the 10 people I happen to grab, they're all fairly cheap in their use of electricity. They don't use their phones too much, or they charge them at school. Their parents are out, and when their parents are out, they turn off the AC, they turn off the lights. And so, even though I grabbed 10 students who were all were supposed to miss in one way, they didn't actually miss. They hit the target right on. The average in Swansea is 75, and the average in my sample is 75. That doesn't mean that there wasn't bias in the design of the survey. It just means that due to the fact that every study has variability, the bias wasn't noticeable in the result. We want to avoid bias in our methods. It's like, let's say I'm aiming at a dartboard, and I was actually just at a Renaissance fair. So let's say I'm doing archery, and I always aim too high up, and I aim too high up this time. But because my hands are twitchy, as they always are, I just so happen to twitch downwards at the key moment, and I hit a bullseye. That doesn't mean my methods are good, right? Variability may have corrected for the bias, but if I shoot again and again, I'm going to miss over the target more than I miss under the target. I'm not going to aim at the target. We want to avoid bias in our methods, and variability is just something we have to deal with. We can try to reduce variability. Also, Chapter 4 is going to talk about bias and how to get rid of it. Later chapters will talk about variability and how much of it there is. But bias is what we want to avoid here. And so instead of taking a convenience sample, we'll try to get a random sample whenever possible. Let's not forget that for every time that I hit the target right on due to hand twitchiness, I'll also be hitting up here due to twitchiness. So relying on variability to correct for bias will not work. We want to eliminate all our sources of bias. So let's talk about one method of convenience sampling: voluntary response sampling. I tell all my students, hey, could you guys please get me your electric bills? And not all of my students go home and grab me their electric bills, just the conscientious ones. Just the ones who want, maybe if I offer extra credit, just the ones who I offer extra credit to. And they come back and they bring me their electric bills. Well, there's a couple of issues here. They decided whether they were going to respond or not. That's going to lead to that is a voluntary response sample, and it can lead to certain types of bias. Because maybe the people who happen to bring me their electric bills are people who are very conscientious, and if they are conscientious, it's because their parents raised them to be conscientious, and if their parents raised them to be conscientious, their parents are also probably the sort of people who turn out the lights before they leave the house, and if their parents are the sort of people who turn off their lights before they leave the house, then their parents are probably also going to have low electric bills, and so without trying to, just by gathering a sample of people who've volunteered or agreed to respond, I ended up with bias. Another example of voluntary response sampling might be in an online poll where they say, hey, who do you support in the upcoming election? And most people who don't care are going to move on with their lives or aren't going to bother expressing themselves. Or maybe people who support Clinton are a lot more shy than people who support Trump. And so Trump supporters are going to respond. while Clinton supporters are going to go on with their day and not respond, and you could end up with a sample that, again, contains bias based on the way it was gathered. So yes, convenient sample is not so good. Voluntary response sample is a very convenient way of gathering a sample, but it introduces sources of bias. On the other hand, we have random sampling. Random sampling is different ways to get a proper, not necessarily a proper mix of everything because it's all due to chance, so you have to pick, but at least a sample that doesn't have bias in its design. Variability is unavoidable, bias is not. So one way to do this would be to number all my students from 1 to however much, and then tell 10 of them, randomly picked, to go and bring in their electric bills, or else get an F for the term 1. That way I'll get all 10 of them. Now there's still some bias there because I'm not gathering them from all of Swansea. I'm gathering them just from my classroom. But let's say I went out there and as a government agency told like 100 families in Swansea, give me your electric bills, or else we will charge you an extra $500 in taxes. It's terrible. We're not planning on that. But that's a way to be able to get people to respond, regardless of whether they want to or not. It's sort of hard to get done. So random sampling is generally hard to get done, and that is why people so often use convenience samples. But let's talk about how random sampling is done in theory. It's a lot easier to do for chocolates on a conveyor belt. You randomly pick, like the chocolates don't get to say, no, don't eat me. You eat the chocolates. So in certain situations, random sampling can totally be done. With people, somewhat less easily, but it can be done. So what is a simple random sample? It's where you number every single one of the chocolates, let's say, from 1 to 10 million, and you roll dice or pick a random number. There are 10-sided dice that you can use to get digits. And we'll talk about the methods in class of getting random numbers. But for simple random sampling, you number them all from 1 to 10 million or whatever, and then you randomly generate numbers and you pick those chocolates, and you test those chocolates to see if they're yummy. Or you randomly pick houses, and you ask the electric company, that way you don't have to involve the people at all, and you can get a proper random sample. You ask the electric company for the bills for those houses. And so where everybody has in this method, all members of the population have an equal chance of being included in the sample. And any sample of 10 is theoretically possible. You might, by pure chance, by pure variability, end up with 10 houses all on the same street in a row. Any combination is possible. Now let's take a look at cluster sampling. Cluster sampling is a way to make a random sample more convenient. Simple random samples are hard to do because you have to be able to number every member of the population. Cluster samplings are easier. Let's say I grab each street and I give each street in Swansea a number from 1 to 5,000, and then I randomly pick 10 streets using the methods of simple random sample. I randomly pick 3 streets and survey everybody on those streets. Why is this more convenient than a simple random sample? Because a simple random sample, you might have to drive your car to 20 different places all over Swansea, or 50 different places if you want to survey 50 houses. But if you want to survey 50 houses more conveniently, you can use cluster sampling. What it does is it still gives every house an equal chance of being picked, because 10 out of, 5,000 streets in Swansea will be picked, and your house has an equal chance of being on the street that is picked as any other. And so it is a type of random sampling. But on the other hand, you only have to go to 10 streets, which makes it more convenient. The method, because it's a random sample and all houses have an equal chance of being picked, there isn't really a problem with bias here, but there could be a problem with variability. Let's say that by chance, 2 of the 10 streets surveyed are like where all those swanky, fancy houses are. You might end up with houses that are, that you might end up with electric bills that are larger than expected. But at least there was no bias in the method. There might be a lot of variability. You might end up with, all the expensive houses with large electric bills, or all the, smaller houses with smaller electric bills. But regardless of what variability might, do, and regardless of where you might be off, there's nothing wrong with that method of sampling. It's more convenient than simple random sampling, but it's random, so it's unbiased. And then there's stratified sampling. Stratified sampling would be if we cut up Swansea into neighborhoods, like we'll cut up into 30 equally sized regions where each one has the same number of houses, and then we'll, using the same simple random sampling sort of method, we'll randomly pick one house from each of those 30 neighborhoods. It's less convenient than cluster sampling. It's even less convenient than simple random sampling, because with this you just have to number them 1, 2, whatever. Over here you first have to subdivide them, then number them, and then pick them out. It's less convenient, but why is it sometimes better than simple random sampling? We use stratified sampling because we want to decrease variability while not creating bias. By using a stratified sample, I make sure I get, one house from each neighborhood. I make sure I don't end up with 10 really fancy houses all from the fancy side of town. And so it decreases variability. There's no way I'll get the 10 awesomest houses or the 10 bleh-ish houses, whatever. We get a good mix. That's the purpose of stratified sampling, to decrease variability. All houses still have an equal chance of being chosen if you've subdivided Swansea into 30 equal-sized neighborhoods in terms of how many houses. And those aren't the only 3 random sampling methods. There are others. For example, systematic random sampling, where let's say you put all the houses in Swansea in a list, and then you're going to pick 30. So do you pick number 1, 101, 201, 301, or do you start with house 17 and then 117, 217? There are other ways to get a random sample, but those are the 3 that we're going to see most often.